All right. This is for Jonathan. Jonathan, we are sorry you're not here, and we were talking about the lab that we started yesterday. So here we go. Part 1 looked like this, and I saw you set up your channel, and then it ended at near the tip of the table, and then it went zing. The ball went zinging down, and you marked it right here where it fell. And you did that 5 times, and you averaged it. Did anyone not get those 5 numbers? So every group, every table got that. All right, so we have a measurement here. It is an average, but I'll just call it a measurement. And we had to measure what else? What was something else we had to measure yesterday? Alex, do you remember? Something else we measured?
We had to measure the height of the table.
Yeah. So we had to measure that. Aaron, do you remember anything else we had to measure?
We had to measure the length from the top of the ball thing to
Right.
the
Okay.
table.
And you were about to say that, weren't you, Aaron? All right, so we have 3 measurements that we have made. Did anyone need one of those measurements? Because you have to set it up again if you need it. Let's make sure it's in meters. So let's do some makeup. I'll make up some data for mine. Let's say that mine, what was your height here? Anyone got it in front of them? Hannah, is yours?
0.13.
All right, I'll say mine's 0.20 meters. I'm making this up. And I said the height of my table is 0.70. Is that anywhere near reasonable?
Yeah, mine was 0.73.
Okay,
Yeah.
cool. All right, and I'm going to say I just made this up, 0.5. It probably wasn't that long, was it?
Was that what we were trying to find?
Ours wasn't that long.
Pardon?
Oh, yeah. Mine was.
All right. Mine, I had maybe a heavier ball or something, and it went out further. But so let's use my makeup data to see if you did your work, if you're going to do your work right. So on part 1, we had to use math only to find the velocity. So even though we went ahead and got the data, we didn't really need it for part 1, which someone pointed out to me. So let's do my mock data. So pull out your calculator so I can have your help with that. So this is part 1. So in part 1, we pretended that the potential energy at the top equals the kinetic energy at the bottom. Is that true? Is that true in real life? Molly, what do you think? In real life, is the potential energy at the top equal? So remember, it changes when
Probably not.
it's not, because what does the dirty work in between? Not gravity.
Friction.
Right. Friction is going to rob energy from this system, but we are ignoring friction in this part 1. So this is La La Land, so let's welcome ourselves to La La Land. And so at the top, yeah, Aaron?
Students will be able to check books out today from the library. Mrs. Karsner will be in the library today between 11 and 1 o'clock for anyone who would like to go in and browse and check out some books with Mrs. Karsner. Between 11 o'clock and 1 o'clock, feel free to stop in there in the library. Also, remind you that it is Pie Day at lunch. We'll do activities and have pie. And also, one last thing. Before the end of the day, please be sure the top of the lockers is clean. That there are no items on the top of the locker. They will be cleaned at the end of the day today. Thank you.
All right, do we know the mass of the ball? Morgan, do we know the mass?
No.
So what do we put here?
We just crossed the end.
Of course, we have the fun of crossing it out in La La Land. So what is left? Abby, can you put in some numbers for me as we go across?
9.8
Uh-huh.
and then 0.90.
All right, like we're going to do, because we are doing the top, here's the PE up here and the KE down here. So we only need this height.
0.2.
All right, and keep going.
1 equals 1/2. And we don't know the
All right, we're looking for V1. We'll call it
It
V1.
wasn't 1/2.
Yeah, we
Instead of
changed it to
a
7
7/10.
tenths.
Oh yeah. Thank you. All right, this is even more La La Land because our ball rolls. I forgot. Thank you so much.
Like that, yeah.
We changed this just for this lab to 7/10. I'm sorry. All right. Go ahead and calculate V. Everyone tapping away. Hold that thought. Tap away. I want you to get this one as well. So you're trying to solve this equation right here for V squared, or V. And we're going to call it V1. V1.
1.7.
Anyone?
I didn't get there yet.
All right, that's meters per second. I totally made this up, so I do not expect you to have the same one. All right? All right, V1 is very important to this discussion. Well, you know how to do it when you go back to your work. All right. Part 2. All right. Lend me your mind there, Miss Annabella.
Yes, ma'am.
All right. We're going to calculate this a whole nother way, and we're not going to ignore friction. So the friction is okay on this side. So we're going to do it again using a more real-life scenario. And I need your calculators out and on again. And we're going to do this the old way, the voting equation, which also works. So we have done that plenty of times before. Remember when we rolled it off the table? We did that lab, and we found the velocity that way. So I'm going to remind you how to do it by using my data, so you'll know how to do it with yours. So if I want the velocity when it comes off the table, is that an X problem or a Y problem? So Annabella, and right here's where I'm going to look for the velocity.
That's
So
an X problem.
It is. It's going horizontal at that point. There's no velocity for an instant in the vertical direction. So we're going to vote with our X's. All right, start filling in. Aaron, do we know X in the X direction?
Yes.
How far?
Jesus.
And
Would it be
my
0.50?
yeah, my fake data is 0.5, right?
Oh no, my baby.
All right, we're looking for a velocity. I'm going to call it velocity 2, so that's what we're going to call it in this lab. It is velocity in the x direction. We don't know time. What's the acceleration in the x direction, Alex? What's the acceleration in x direction on anything that's in parabolic motion? No, that's the y direction.
Zero.
Right. So we're basically done all we can get with this x sub x formula, but we don't know v and we don't know t. So where do we go to find t?
The Y.
Y. So we take the same voter.
Why do we go to the Y?
Yeah. We go to the y to find the t. All right. All right, Brendan. Brendan, you
Yeah.
start filling in numbers. Do we know x, the distance in the y direction?
Is it 0.2?
It is the fall from here to here, which is, and mine is what?
0.7.
All right, and it went downward, so use a negative sign. All right. V, this is V2, no, that's V2 up here, sorry. All right, Molly, what is the velocity, just for an instant, when it comes off the table in the y direction?
Is that the 1.7? Or no?
No,
Or no.
it's a theory question. It's a theory question. It's coming down, yo, and then it goes just for an instant.
Have we been talking about?
Molly, just for an, oh yeah, we forgot to time it. Oh. Why don't you just stop it where it is and